So we want to find a limit as x approaches 2 of radical x minus 1 over x minus 2. So the first thing we do is we do a direct substitution, and if we plug in 2 in for x, you get radical 2 minus 1 is radical 1 minus 1 over 2 minus 2, which is 0. So over 0. So this is an undeterminate form, which means that we need to do some work. One will be try to factor, but that does not work here. We can already factor. 2, if we are dealing with radicals, you're gonna use the conjugate, and that's what we're gonna want to use here. So what the conjugate of radical x minus 1 will be radical x minus 1 plus 1. So I'm going to multiply both the numerator and the denominator by the conjugate, which is, as I said, radical x minus 1 plus 1. Why do we do that? Is because here it's like a minus b times a plus b, and that's, if you were to FOIL, this is the difference of two squares, so it's going to be the equals to the square root of x minus 1 squared minus 1 squared, and I'm going to leave the denominator the way it is. I'm not going to FOIL or anything at the moment. I'm going to leave it the way it's written. And then when you square a square root, then they cancel. So you have x minus 1 minus 1, that becomes x minus 2. And you see why I did not cancel, I did not distribute the denominator, because now we can see that we have a common factor of the numerator and the denominator. And that's usually the case here when you are factoring, or when you use the conjugate, or when you use the LCD, when you're dealing with a rational expression. What you do that because you're gonna have common factor that are gonna show up. So that's why usually you don't want to FOIL everything out, because the goal is to actually cancel common factor. And so here that means that we are set with looking at the limit as x approaches 2 of x minus 2 over x minus 2 times the square root of x minus 1 plus 1. And here you see that the x minus 1 cancel, and we're left with a 1. So this is the same thing as the limit as x approaches 2 of 1 over radical x minus 1 plus 1. And now we can just do a direct substitution, plugging 1 in for x. And this is the square root of 1, which is 1, so the answer will be 1/2. So this is what happens when you are dealing with an indeterminate form, such as 0 over 0, infinity over infinity. First thing you try to do is simplify, FOIL, maybe expand things out, combine like terms, then try to factor. Here there's nothing to factor, so here, depending on what you have, then if you have a radical, use the conjugate. If you have a fraction within the fraction, multiply by the LCD. So, but the important part, when you have 0 over 0, that really means that you are dealing with an indeterminate form. That means we do not know what the answer is, and that means we're going to have to do more work. And so what that means by that, we're using algebra to solve the problem.